Hi everyone, let me introduce myself to those who do not know me. I am Ashnat Kothari, a qualified fellow actuary. I am the founder and director of Finatics. Finatics is involved in providing classes for actuarial exams, placement assistance, along with plenty of other services which a student needs at different phases in their journey to become a qualified fellow actuary. I have been professionally teaching actuarial science for the past 8 years, having mentored students not only from all parts of India but from across the globe. Now, coming back to the much awaited announcement, the reason why you are here, we are extending an opportunity for students who have not studied with us to join our classes, get mentored by us for the preparation of actuarial exams by paying zero tuition fees at outset. Yes, you heard it right. Zero tuition fees at outset. This is valid for classes of CM1, CM2, CS1 and CS2, whether you are appearing from IFoA or II. Ones who would be joining us for the first time can see how we go about with our classes, the educational content we provide, the doubt clearing facility we provide, the sort of guidance, unbiased guidance we provide. And after spending some time, if you find value in the educational content and guidance we provide, you can pay the full fees. Now, you might be wondering as to why we are coming up with this opportunity, even though Fanatics is at its peak with respect to the performance of its students in actual exams as well as their professional career. The reason is simple. You will not see us extensively marketing over social media, be it through Insta Reels, YouTube Shorts, or other various ways. You will not see us coming up with new batches on a regular basis or flexing the number of students we have and outrightly ignoring the proportion of students who clear the exams or who even continue with their journey. Being in the education industry, we make a conscious effort to channelize majority, if not all, of our energy and time towards ensuring that students are having a proper learning journey, not just spoon feeding them everything so that they might get certain favorable results in the short term, but by ensuring to make them independent, capable of working independently, even in our absence, and therefore succeeding both in their personal and professional journey in the long run. Do note that we continue to have one single batch for each paper each term to ensure that all our students are getting sufficient time from the faculty. Do keep in mind that at Fanatics, it is the main faculty, be it Gunjan or me, who are involved in taking the classes, doubt clearing, or any sort of guidance or any sort of assistance which the students require in the preparation of their actual exams. As such, we will restrict the number of intakes to 50 for each of the papers. In case you are already studying from us and you are happy with the way we go about with our classes, continue to study from us. For ones who have not studied from us but who are looking forward, this is the best chance for you all to join us, experience how we go about with our classes. If you are a sincere and hardworking student who wants to excel in your actual career, do join Fanatics today for a meaningful, impactful, and wonderful learning experience.
So let's get started with the discussion of IFoA April 2024 CS1 paper discussion. Before we get started with the solutions, let me just give you a brief highlight regarding how I saw this paper to be. So paper A, I would say it was easy. The type of questions which they give was slightly different as compared to the previous years, but those were, more forcing the students, or rather testing students on their fundamental concepts. So nothing different, nothing difficult, nothing, let's say, out of the syllabus, out of the world type. But yes, the type of questions which they give, you will not find a lot of these questions in the past year papers. But again, these were testing the pretty basic concepts. It took me around 75 minutes only to solve the entire paper. Again, this was on paper and not on Word. On Word, it would have taken definitely more. But yeah, that is again just to give an idea. Obviously should not compare with the amount of time I would be taking. I have been, doing this for a long time, 8, 10 years. since I have been in practice. So obviously, the time which I might take would be different than yours. And obviously, the fact that I am not sitting for the main exam where my speed might be slightly lower because I would be pretty, trying to double check all the things which I've done, whether it's correct or not, without the pressure. I mean, I haven't really felt the pressure as such, even when sitting for any actual exam, even if I was not very well prepared for same. But yeah, again, the point is key. I thought this paper for well prepared students was extremely easy. I mean, CS1 each term, I just feel like, they are giving pretty straightforward questions, but yeah, this assumes that a student has a very good knowledge about random variable distributions. They know the fundamental concepts. Paper B is also something which a lot of students came back and said ki they found the paper relatively easy, so I expect the pass marks to be around 60 only, plus minus couple of marks here or there. So yeah, that's my view on this particular paper. As for those who are watching this video, make sure you are taking a look at the comments section as well. In case you find any calculation errors or any sort of other things which you feel you disagree with the way it's done in the video and you feel it's incorrect, do let us know through comments section. We'll definitely take a look into it as and when I get time. And in case there are any amendments, we'll be pushing in the comments section itself. Do note that I haven't got much time to review my answers as such, given slight shortage of time. So there might be some mathematical errors or maybe some other sort of error as well. So, feel absolutely free to, inform us through the comment section. And definitely, in case you find this video useful, do like it. I mean, do subscribe to our YouTube channel as well so that you are updated with all the latest educational videos we keep, sharing through our YouTube channel. So let's get started. Question number one, uh, a different type of question, the way it has been given, but using the very, very fundamental concept of expectation, conditional expectation, conditional variance. So let's quickly take a look at the solution. I've tried to give a pretty, detailed solution, not very detailed, but yeah, optimum, the way it's maybe expected even in exams, so that each and every step gets captured. So this is for expectation X. This is for expectation Y, using the fact that expectation Y is expectation of expectation Y given X. Then we know this is the formula for variance Y. Variance Y given X is given. Then if I'm finding variance of expectation Y given X, I'm using first principle that variance of a random variable, let's say variance A, is nothing but expectation A square minus expectation A whole square. Or you can also write this as summation of, probability capital A equal to small A minus A bar whole square. So there are two formulas. So one is X minus X bar whole square, and this can be even further simplified to be written as summation xi square minus x bar square, and which in terms of expectation it gets reduced into the known form of e of a square minus expectation a whole square. So over here I've written in this form. You might expand it as well, but I thought this might be give you a more better way to visualize things given there's a conditional how it's coming along and all. So there it is. It's coming as 13. So part 1 it's A and part 2 I'm getting the answer as 13. So this is where I did think a lot of students could not solve part 2. Question number 2. Now over here, let me inform you that I do find this PDF to be incorrect. Given the structure, I think it's a gamma distribution, but the parameters are not tying back. I mean, it's y to the power 2 minus 1. So I mean, alpha is 2 and your lambda is nothing but 4 by m, but it's not tying back. I mean, this should have been not 8 by m to the power 4, something else. So integrating this PDF is definitely not giving one. I haven't got the time to spend a lot of time on it. I did spend some additional minutes, but yeah, I did cross check with one or two my peers as well, and it seems that something looks weird with this PDF, but nonetheless, I mean, we could use it to express in the given exponential family form. And over part 2, it was more on the commenting part. So in model A, all the different types of copy will have the same mean time, wherein model me, different types of copy will have different mean time. So taking a look at part A over here. So it says theta b theta a phi cy comma pi. Note that ln 8 plus ln y can be written as ln of 8y. So I mean, you might ask, why have I split it? I just split it, then I realized, okay, no, ultimately it's all of them coming in the C term only. I might, combine it to write in a single term itself. So yeah, that is sort of a inefficiency, you might say. It was not needed in the first place to, expand ln 8y as lny plus ln 8. Next, question number 3, again from joint distribution over here. I expected students to score pretty good marks in this part, but the couple of scripts which I have seen, it was disappointing. They were not able to get part two or part two specifically correct. Even part three, I mean, because it was using the results from part two. Independently, part three could have been done, but because it was done using the results of part two, so yeah, some of them did make mistakes over there, which was disappointing, honestly. So this is part three. What I've done is first, I've computed these conditional probabilities. Part two, I've got again the conditional expectations, and then part three wants us to use the results from part two. Now note that these 3 by 5, 1 by 10, 1 by 10, 1 by 5 are nothing but conditional probabilities. Question number 4, again, pretty easy question, I will say. But yeah, part three was where the trick was there. They had honestly given the hint. If you would have just started by writing the hint using the fact that correlation is nothing but covariance divided by standard deviation AB, you would have got this result. I mean, a lot of scripts which I saw, they had left it blank, which again I would say for ones who are very well prepared, or who are decently prepared but have good strong underlying concepts. I mean, using the hint, if you would have tried, and I don't think so timing would have been shortest for anyone who have practiced over word, you should have been able to solve it. So if I take a look at question 4, this is for part A, this is for part B, this is for part 2 over here. Part 3, I start with correlation. I take the covariance divided by a standard deviation, and then I multiply this on the other side. Now over here, I express covariance A comma B as covariance X comma Z minus 0.72 from the earlier part, and solving this, I'm getting in the particular form where they have asked us. Next, question number 5, which again a lot of students did find challenging certain parts of it. Part 1 specifically, state two properties that a loss function should specify. So I went back and I checked the material. I mean, I knew what the properties were, but I didn't recall, whether these are explicitly written or not. Okay, these are the two properties. And yes, that was not the case. They had not written, okay, these are the properties of a estimator. But what they had written was, for an estimator, we would expect that at the central point, it should give a loss of zero and it should be an increasing function. I mean, basically something like a U shape or a V shape. Point is, yeah, as we are moving further away from the central estimate, the loss value should keep on increasing. The absolute value of the loss should keep on increasing. So part one was L mu comma mu is zero, and the first derivative is positive when g is greater than mu, and the second derivative is negative, which basically means that as we move away from the central estimate, we want the loss function to keep on increasing. So this, I would definitely agree that a lot of you would not get it. Not something which has been tested previously, and it's very there given in the material. And again, the very reason why I insist all of to read the material, however much you might like my notes and you might find it completely exhaustive. But again, material is material for a reason. It covers far more things compared to what would be there in notes. I mean, for all practical purpose, our notes would cover most of the things, but I always suggest to have a complete clarity of knowledge, to get the bigger picture, not just certain things, but a bigger idea, more in-depth concepts. Definitely read the acted material. It's there given for a reason. Definitely leverage the learnings you can derive from it. Part three was pretty straightforward, I would say. I mean, you have the loss function to find its expectation. Part four is something which I would like to highlight. I am not very sure of its answer as of now. It seems that if it's just finding the normal quantile, which is, let's say, the first quartile over here, that is my understanding of the question so far. So I mean, over there we could very well use this formula, probability mu less than b given x bar is equal to 0.25. But I'll have to spend some time over this. So maybe later I might push in through the comment section. But this is something I'll have to say honestly. I'm not sure as of now. whether B is completely correct or not. I would just want to, spend some more time to be very sure whether this is in fact the correct one. So as for 3, it's part D. Moving forward to question number 6. Again, I will say a similar type of question has been there in the past, at least parts 1 and 2 that way. But many of you didn't get it right. Part 1, uniform 0, comma 1 should be used because P is a proportion and we would expect it to lie between 0 to 1 itself. This is part 2, you're getting the likelihood, the prior, the posterior. For a beta, I mean, under quadratic laws, it's nothing but the mean itself. Mean is alpha divided by alpha plus beta. I remember this too, the formula. In case it's wrong, do let me know through comment section. I didn't really check the actual tables as such. That's what I recall, that it should be alpha by alpha plus beta itself. And now in part 3, finding the posterior mean, it's coming as 13 plus 2b divided by 30 plus 3b. In part 4, now again, if you are looking for low uncertainty with the estimate, the sample data is same. So we'll prefer to use that prior, which has a lower prior variance. So now for uniform, the variance is 1 by 12, and for beta prior, using the values for variance given in the actual tables, it's coming out as 1 by 18. So therefore, we would prefer to use the beta prior in the case B was taken as 1, I guess, in the question. Yeah, in the case B is equal to 1. Question number 7, again, something which should have been scoring a similar type of question. Again, when I say similar type of question, it does not mean that the entire question with all its parts has come, but whatever parts are there, it has been there in the material in the pastoral papers. So it is something which is you should have practiced already. It's there, so it's not something new. So question number 7. Let me take a look at the solution. Part 1 is definition of conjugate prior, which is direct book work. Part 2, I'm finding the posterior. It's again gamma, and I show that prior is also gamma, posterior is also gamma. Therefore, it's the conjugate prior. Part 3, computing its mean and variance, which is standard for gamma. It's alpha by lambda and alpha by lambda square. Part 4, I mean, as the sample size keeps on increasing, the prior will have less and less impact on the posterior. Part 5, but you had to use the property of, let's say, gamma integral, or you might even say gamma distribution, whichever way. I mean, ultimately, it's the property of gamma integral which you need to use over here. So it will be S by A minus 1. And similarly for part B, I mean, you can go in the same format and it would be part A. Next, question 8. Again, no, 8, 9, these are the typical questions which tend to come. I will be, definitely say, and I guess most of you should agree that the amount of typing you had to do was pretty less. There were not much symbols. Even the certain numerical questions, these were plain numbers, or at the most they had expectation y given x, so on. Very less of theta, alpha, all these symbols you had to write. So, I mean, it was a very short paper on it. So obviously, when you don't know a question, you might end up spending a lot of time. But apart from that, I mean, once you know how to do it, it would not have taken much time. Like on paper, I've done it in 75 minutes. I don't know how to do mathematical typing, but I'm sure even if I was doing for the first time, I would have definitely completed this within 2 or 30 minutes. And for those of you, who have practiced well, if you know, I mean, conditional, if you know the question, you should have been able to, complete the paper even in 2 hours. And one of the students, that student did mention that he or she was able to complete within around 2 or 20 minutes. They didn't get completely all the questions correct, but yeah, around 90% of them was kind of, correctly done. Comments part here or there was obviously haywire, but again, the student was able to complete within 2 hour 20 minutes. So again, this paper was such, if you're well prepared, you know things and you know how to go about typing efficiently, it was definitely manageable in a very short span of time. 3 or 20 minutes again you're getting, but within that also it was doable. But again, once you are not able to do it, don't get disheartened when I come and say it should have been done. My caveat is you should be very well prepared. Your fundamental concepts are very strong. If not, obviously, you might find challenge in 1 or 2 questions, and then you might end up spending a lot of time on those questions as well. So, question 8, let's quickly go through it. This is part 1. Part 2, we have negative correlation. You might even say to be slightly strong negative correlation given the R value is minus 0.87, or if I look at R square, it will be something in the range of 75% or so, I guess. So yeah, that is there, which you could say, you might say it to be, slightly strong correlation if you want to put it. This is part 3, I get the result. This is part 4, part 6, y equal to alpha plus beta z, and these I'm getting the result, the regression equation, and part 7, it's using the formula, and I'm getting the prediction interval to be 3.03 to 21.81. Again, I have not honestly got a chance to review these numbers, double check them. So definitely, if there is any error you feel, I would also, just suggest anyone who raises this question, just maybe, double check your solutions as well. And in case you find any errors in the methodology or in the calculations, please let us know through comments section so that we can take a look into same and, rectify if needed. Next, last question, question number 9 over here, 20 marks over here again. Straightforward question using hypothesis testing, confidence interval, paired data, nothing different, nothing weird, I would say as such. Part 1, straightforward, just find the ratio. Part 2, we need to use this fact. We need to state the assumptions as well because the question is asking for it. And in the 95% confidence interval, it is in this form because you have 0 lying on it. Therefore, we will not have sufficient evidence to reject H naught. And therefore, we cannot conclude that both the proportions are different. In part 5, we're using the paired test. Now, over here, we have sufficient evidence to reject H naught. And then in the later part, it was commenting, whether the paired data would be more appropriate or not. I guess that was part 4, and part 6, commenting on the results. So yeah, this was overall paper. The good thing about such papers is it for me also takes less time to solve it. Else other papers, like CM2, it is one of those papers where even it takes me close to 3 hours or 3 hour 20 minutes to solve it. At least the last 2-3 years of paper. But other papers like CM1, CS1, CS2, it does not take that much amount of time. So that is just to give an estimate. When you are also, sit for other papers, you will understand that this paper generally was not a lengthy one. You will realize with other papers that they are genuinely lengthy. And even if you're doing it on paper, forget when you have to do it on Word. So that is just for you to get a reference, get a fair sense of reality check where you are with respect to your preparation so that you can you just know the true facts and you can work accordingly, that you have a fair idea whether your speed is optimum or not, and so that in the later papers you just don't get shocked, because students do end up clearing CM1, CS1, CB1, CB2, but once they are preparing for CM2, CS2 is a challenge in itself, or when they prepare for higher papers like CP1, SP, SA, or even CP2, 3, I mean, these papers are very different. They all require very different preparation strategy, different sense of the way students produce answers as compared to these CM and CS papers. So yeah, you need to keep that in mind. And as you study these papers, you need to develop this your capabilities as well so that you can tackle the higher ones paper. Else, there are so many students these days, you'll find them clearing 8 or 9 papers, CM12, CS12, CP12, 3, CP2, CP3. And the moment CP1, SP papers comes, forget even giving the paper. The when they're studying for it, they find so lost because a lot of them are just so much into, with let's say their tutors spoon feeding them everything. They just feel like, what is there in the material and past year questions, those things only should be asked. But sadly, that is not how the profession is. That is not how the curriculum is. That is not what is expected out of, true actuaries. Replicating past things is not something which we're expected to do. So they find it difficult to even prepare. I mean, forget giving the paper, they just find it absolutely difficult. No, there is nothing concrete. There's no concrete yes or no. We need to develop so many points, relate so many different ideas, and they find a challenge in that. So intention is key. First paper, when you're giving CM1, CS1, it's okay. You will start at a different mindset. But as you progress further, you need to develop your capabilities, to critically analyze things as well, and obviously be aware about where your current capabilities are, where your current skill set is, what your mistakes are, so that you can work on them. Eventually, it's about you working on your own mistakes and not just thinking what others are making mistake on, and that is fine if even you are making. Idea is to improve ourselves. Some of us have different challenges. Some of us face different issues when solving the paper. So the idea is for us to recognize or identify what challenges we face. Next step is, obviously how we could improve on it. And then the most difficult part, I will say, after identification is executing it. You know what is wrong with you, you know what needs to be done, but just doing that is the difficult part. So, I mean, ultimately, you need to execute. That's true for each and every field. Idea is one thing, everything is one thing. Ultimately, you need to, execute. So I hope you all found this video useful. That's it from my end. Thank you.